So in this example over here, we're given that P is equal to 18.90 newtons, Q is equal to 8.20 newtons, and we're also given the angle between the two, and we're told to calculate the resultant force. Now from our previous video, we know that the formula is R square is equal to P square plus Q square plus 2 multiplied by P multiplied by Q multiplied by cos theta, right? So we have R square is equal to, is equal to 18.90 squared plus 8.20 squared plus 2 multiplied by 18.90 multiplied by 8.20 multiplied by cos of 50 degrees, and what you get, and then obviously we'll take the square root of this entire thing. So you can do it in one step where you just take the square root immediately, or you could calculate this and then take the square root. It doesn't really matter, and then you end up with the answer of 24.804 newtons, and then we're just going to round off the 2 decimal places, so we're left with 24.80 newtons. And that's it for that question over there. So in this question over here, we're given what P is equal to, we're given what Q is equal to, and we're given that the resultant force of P and Q is equal to 20.38 newtons. What we're not given is the angle in degrees between force P and force Q. So it is quite similar to the previous question that we did. So we'll start off with the formula R square is equal to P square plus Q square plus 2PQ cos theta. Now, if you'll read this question again, we have what R is equal to, which is 20.38. We have P and Q, which is 15.30 and 7.30. Obviously, 2 is just a constant. We have P and Q again. The only thing we don't have is this cos theta over here, right? So if you rearrange this equation, you would take these two to the other side. So R square is R square minus P square minus Q square. Remember, when you take positive things to the other side, it becomes negative, is equal to 2PQ cos theta. And then we would just divide by 2PQ and 2PQ. And so we'd end up with R square minus P square minus Q square all divided by 2PQ is equal to cos theta, right? And then we would just sub in our values. So R square is 20.38 square minus 15.30 square minus 7.30 square all divided by 2 divided by 2 times 15.3 times by 7.3, and then we'd get that this is equal to this is 0.5728, and this is obviously equal to cos theta. So we'd have to take the arc cos, or inverse of cos, of this number over here, and we'd find that this answer is equal to 55.05 degrees. And that is your answer for question 3. So we're given force F, which is denoted by 17 newtons by 22 newtons. So if you think of that force looking something like this here, which is 17 over here, and you got your 22 over here, right? Previous lectures, we know that the resultant force will look something like this, whatever this number is. First of all, to calculate this resultant force is pretty straightforward. We're going to take 17 squared plus 22 squared, all in their square roots, and it's going to end up with 773, right? So that's what your actual force of your F is equal to. And then if you remember our formula from the previous lecture, we had F1 or Fx or F of I, and the reason why F of I is here is because the unit vector I refers to the horizontal component, or the x axis, right? All of this is equal to f multiplied by cos theta. Now we're given what f of I is equal to. It's 17, and we're given what we calculated what f is equal to, which is this number over here. What we need is this over here, right? So simple math, we take the theta is equal to the inverse of cos of f of I, which is just 17 divided by 773, and this should give us that theta is equal to 52.30 degrees, 52.3057 dot degrees, and we just round this off to 50.31. Sorry, 52.31, and that's your answer. So this question over here is pretty much the same as question 4. It's just that we want the angle between the force F and the unit vector J, which would be a Y component. So first of all, we'd start off by getting our resultant force, and it's pretty straightforward. Square all this on the square root is equal to 13 square root 5, and this over here is your resultant. And now if you remember our formula again, it is f of f vertical or fy or fj, whatever you're comfortable with, is equal to f multiplied by sine theta. We have f calculated here. We have j given to us already as minus 22. All we need to do is calculate this over here, right? So theta is equal to the inverse of sine of f of j, which is minus 22, divided by f, which is 13, and multiplied by the square root of 5. If you sub this into your calculator, you should get minus 22 divided by 13,5. You get minus 49.1849 dot dot, and then you're going to add 180 degrees to this, and so you're left with 130.815, which we'll just put as 130.82. So yeah, that's it. So in this example, we have a force in this direction over here, and we're told that the angle it makes with the vertical line going up is 40 degrees. And we also know that this here is a right angle triangle of 90 degrees. So if you wanted this entire angle over here, we just add 40 plus 90, which would give us 130 degrees. So that this is the complete angle that the force makes with the horizontal axis. And then we're told that we want to calculate F1, right? So we know that F of F1 is equal to F multiplied by cos theta. Now, do we have F? Yes, we do. It's given as 48. Do we have this theta? Yes, we do. 130 degrees. So if you just sub that into your calculator and say F1 is equal to 48 multiplied by cos of 130, you should get minus 30.8538 dot dot dot. And then of the two decimal places here, we just have F1 is equal to minus 30.85, right? And you may say, well, why is there a minus here, right? Shouldn't we have a positive? Not exactly. If you look at the force, it's going in this direction over here, right? So if you think of your Cartesian plane, your y-axis here and your x-axis here, we know that going up is positive and going to the right is positive. So if this force here is going to the left, you should expect a negative answer. This doesn't mean that it's a negative force. It just means that the force is going in the opposite direction to the positive axis. So yeah, that's pretty straightforward.